Okay, so we need to solve this differential equation. dy dx equals e to the x cosec 2y cosec y. And we're given y equals pi over 6 when x equals 0. Okay, so where do we start? Well, we need to get the x's and y's on the same side. So we can multiply both sides by dx to get ex and dx together, and then divide by the cosecs to get them over here with the dy. So let's do that. So we'll get e to the x dx on this side, and then cosec 2y cosec y, dividing that, we'll get 1 over cosec 2y cosec y dy. Okay, now we need to get rid of these dy's and dx's. Easiest way to do that, integrate both sides. Okay, so we've got this to take care of. That looks a little bit tricky. This one, everyone's favourite integral. We just call that e to the x, and we'll say plus c. Finished. Cosec 2y cosec y. So let's take care of those over here. They are equivalent 1 over sine 2y, 1 over sine y. So that's okay. So we can plug that into our integral. 1 over cosec y, 1 over sine y. Sine 2y. Now a little bit tricky here now. We've got y is pi over 6. We haven't got what 2y is. So what we need to do is use the double angle formula. So say sine of 2y is the same as 2 sine y cosine y. That's what sine 2y is. So now what we can do is 1 over sine 2y, we can plug it in. And then the dy. Okay, now a little bit messy, fraction divided by another fraction. It's not really what we want for integrating, but what we can say is that a divided by b over c is the same as a times c over b. Well, with a and b are both 1, so the c is this. We just put that on the top. We should have just a straightforward looking integral. 2 sine y cosine y sine y dy equals e to the x plus c. Okay, so 2 sine y times sine y will give us a sine squared y, and then we got sines, just one term for sine and one term for cosine. So let's just tidy that up a little bit. 2 sine squared y cosine y dy equals e to the x plus c. Okay, now I think we're ready to integrate this now. So if we put in a u sub for sine, then we can get a cosine for the dy. So let's just show you what that is. So u equals sine y. Derivative of u equals cosine y dy. So now dy equals du over cosine y. So now we've got the dy taken care of, and the sine of y is u, so sine squared of y will be u squared. So that will give us the integral going into the u world, 2u squared. Cosine y, I'll just leave in for now. Y is not invited in the u world, but you see here what will happen when I put the du in. Du over cosine y. Take care of this in a minute. Cosine y's cancel out. And now we've just got a straightforward integral 2u squared du. Happy days. So, integrating straight off, 2 stays, the u stays. 2, we add 1, which is 3. And divide by the 3. 2/3 u cubed equals e to the x plus c. Okay, so we're nearly solved. We need to put in, go into the u world, from the u world, sorry, to the back into the y world, and then see what we can do when we plug in these values. So we've got 2/3 u cubed. U is sine y, so that's sine cubed y, equals e to the x plus c. Okay, e to the x, let's deal with that one first. So e to the x, so we're given x equals 0, gives us e to the 0, which we know is 1. Sine of y, so y is pi over 6. Sine of pi over 6. Well, we know sine of pi over 6 from the unit circle, that's a half. But what we need is sine cubed. So sine cubed pi over 6. That's the same as 1 cubed over 2 cubed, which equals 1 over 8. So now let's just plug these values in now, because now we know what they mean. So we've got 2/3 times 1 over 8 equals 1 plus c. Okay, 2/3 times 1 over 8, well 2 1s are 2, 3 8s are 24, that gives us 1 over 12. So 1 over 12 equals 1 plus c. So therefore c equals 1 over 12 minus 1. So therefore c equals minus 11 over 12. Okay, so that's our answer.